Welcome everyone to a technical webinar today on baghouses. My name is Tom Zhang, Senior Engineer for Optimus Solutions. I got a couple guests here with me. I got Mike Atwell, Director of Engineering. Mike, say hi.
Hello.
And then I got here Tony Fritsch, Technical Sales Support.
Afternoon.
Really, you got the parentheses by Tony saying our residential baghouse guru is the other title Tony has. Mike and I are just along for a ride today. So for baghouses, just to give everyone a little bit of housekeeping on the backside, we do have our webcams on. I don't know if you want to see all our faces. In the panel on the side for the attendees, there is a couple of handouts. One is the presentation itself, and the other is a brochure on the spare parts and services that we offer. So let's get started. I think a lot of you guys that have baghouses kind of know where it sits. For those that either are kind of new or just kind of want to get an overall overview, this is just to give you guys a general idea. So typically, you got a feed, you got a burner. It could be on the burner, could be on the feed end or the discharge end. It goes through a rotary unit, dryers or kilns, and then the discharge is the solids coming out. The fines through the airstream, typically either there's a knockout box right at the discharge side or some cyclones that will primarily filter your big chunks of dust. And then your secondary filters, your scrubbers, your electrostatic precipitators, your baghouses, that's where it collects the, even finer fines. And then everything from the airflow standpoint is pulled through with the ID fan. Again, this is a baghouse presentation, and we're going to focus exclusively on that, but do know that there are many other components, and there are many other components that we actually know quite a bit about too. Just another point here to reiterate, dust collectors are used obviously to collect dust, but a lot of times you got some EPA regulations or some emissions regulations that you do have to follow. One major point is if your dust collector, if your baghouse goes down, your process will be down. That'd be right, Tony?
That's for sure.
Right. So I would say dust collectors are your critical path. If they're down, you're out. So that's another reason why we focus on this. Quickly, we're going to go through. These are your primary dust collectors, cyclone knockout boxes. These are typically stationary with no moving parts. It's geometrically made to get the larger particles out. And then again, these are some of the other types of collectors. Wet scrubbers, you effectively use moisture or water to go through, decrease the dust. Electrostatic precipitators, you got a voltage difference that you try to adhere the particles towards. And then obviously your baghouses, which we will cover in depth. So I guess Tony, you want to start off on the principal operations?
Sure. So we've already gone through our primary collector, got the heaviest of the fines out, and that's important because we don't want those large particles or pebbles, as they might be, going into our baghouse. The baghouse has a filter media, a cloth type filter media that the dust is trapped by, and so those larger particulate, they would tend to beat up that cloth and shorten the life of the bag. So we've got this in this case we've got our airflow from from left to right. Our red lines indicate the air coming in. The air coming into the baghouse is forced to the bottom, so that it flows up toward the top and through all of the bags. Clean air comes out of the bags, and the dust gets caught on the outside of the bags. And the clean air it goes across the tube sheet and out the induced draft fan.
Right, and there's I think we got a little bit of a detailed view of that.
So here you can see we're forcing that air down by a baffle inside of the baghouse. So as the dirty air comes in, the bags are protected from the dirty air impinging directly on the side of the bags by a baffle.
So does that mean if they don't have a baffle, there's a very good chance it will decrease the life of the bags?
It surely will. Yeah, that's basically like sandblasting your bags.
Do they get holes in the side of the baffles over time?
They do. It's you're getting direct impact of dust on that baffle plate, so it's certainly a wear item and needs to be maintained.
Worth inspecting. Yeah.
So then, of course, that air is now making its way up through the bags, and the dust getting trapped on the outside of the bags, and then you can see the blue lines up at the top. That's an indication of the air coming through the tube sheet. The tube sheet is the steel plate that all of the bags are connected to. So that air goes up through the tube sheet, and then you have clean air on top of the tube sheet, dirty air below the tube sheet.
So if you got some dust coming out from the top, that's probably
got a problem with your bag.
If you open up the lid on the top someplace and you got dust up there, you got an issue with your bag.
You've got a leak. It's either a leak in a bag, or you may have a leak between the seal between the tube sheet and walls.
Oh, that's good. I mean that's kind of an obvious one. Cool. So in the baghouse world, you got kind of two major types. Would that be right? Would you go through a little bit on that?
Yeah, so we clean the bags by pushing air down through the top of the bag, and that air pushes the dust off of the outside of the filter media. And so you can do that a couple of different ways. There's a reverse air baghouse, and that uses ambient air to pulse the bags to clean the bags. And in that case, you've got a pretty high volume of air. It's not really shocking the bag. It's just creating a positive pressure inside of the bag, pushing the dust off of it. So it's a higher volume of air and low pressure, and it's easier on the bags. So that means the bags tend to last longer. But as we've got noted here, it's sensitive to the environment. So if you've got a baghouse that's located in a high humidity area, you can tend to mud up the baghouse or put a lot of moisture inside because you're bringing in that humid air.
Right. So this is like you go at Louisiana, your high humidity areas, or even like in the wet season, right?
And in difference to that, we've got a pulse jet baghouse, and a pulse jet, again, we're pushing air down through the center of that bag, but we're using compressed air in a pulse jet baghouse. So that compressed air, it comes in at a very low volume and a high pressure. What we're trying to do with that compressed air is to shake the bag, not to poof it out, not to create a positive pressure inside of it, but to shake the bag to get it to knock the dust off. And so it's a little bit harder on the bags because you're physically shaking them with it, and you've got high pressure, but you don't have the problem with the humidity.
Right, because it's in the compressor.
It's dry compressed air.
Right. So I think you were talking a little bit before we started the webinar on this particular design. So this is like a constant air in the middle, the fan, and it just rotates around throughout.
Yeah, so this is just an image of one type of reverse air baghouse, and we're pulling ambient air in this case, but that turret on top, it rotates around in each of the compartments where the bags are located. As it turns around, it blows high volume, low pressure air in to clean those bags.
That does bring up a point. That is not the same as your ID fan. That's a separate fan altogether. Separate fan altogether. And then this is the pulse jet with these this compressor can, or what's the right terminology?
Yeah, so that's a compressed air manifold. We're filling that manifold with compressed air, usually about 90 psi, and then each of the rows of bags has a blowpipe over the top of it, and that blowpipe has a hole over each individual bag And each of those blow pipes are connected to a diaphragm valve. So when it comes time to clean the bags, we energize that diaphragm valve. It blows a short blast of compressed air in there and cleans the dust off the bag.
And they don't all come on at the same time. It's every other one or whatever arrangement that's set.
Yeah, they need to be. They're set up to skip around so that you're not having 2 rows of bags right next to each other being cleaned. You just transfer the dust from one bag to another.
Right. So if you do it in sequential order, that's probably not the best way to do it.
How long do the diaphragm valves stay open? Is it?
It's just instantaneously, seconds.
Cool. So this right here is kind of what you've been talking about with the pulse jet, with either a mechanism where it blows the material off to clean it, or a way to get the dirty air filtered through to make it clean, right?
Yeah. So on the image on the left is in filtering mode. So the air is being sucked up through the tube sheet. It's pulling the dust in and caking that dust around the outside of the bags. On the right-hand side, we see it in cleaning mode, where we've opened up one of those diaphragm valves now, and that air is filled up the blow pipe that's got the small holes or nozzles over the top of each individual bag. And that compressed air goes down through the center of the bag and shakes the bag so that the dust comes off of the outside of the filter media.
Actually, very straightforward. It's just the details.
Mm-hmm.
So when we go through the baghouses and the bags, so we talked a little bit about the 2 different types. We talked a little bit about the mechanism at which it cleans and filters. So what are some of these, I have here just some of the talking points on maintenance considerations. I think we just talked about one that wasn't necessarily on here, but the baffle plate, if it gets thin, or if let's say you got a hole in it, you effectively created a sandblaster in a sense, because it's pretty fast air going through.
Yeah.
Air pressure management. So this is your high pressure on the compressed air. Is that right?
For the purpose of protecting the bags, yes.
Okay. And then pulse timing. I like what you talked about, the pressure drop or the timer in terms of how you want to pulse it. You want to go a little bit deeper into that?
Yeah. So I guess the most efficient way to use the least amount of compressed air is to pulse these bags based on the differential pressure across the tube sheet. And if you look at the previous slide that we had up there, Tom.
This one?
Yep. So you see that gauge there, that's pulling a pressure reading above the tube sheet and below the tube sheet. And so the most effective way or the most efficient way to use the least amount of compressed air is to set that gauge up so that it, at a certain differential pressure across the tube sheet, you pulse, you clean your bags.
Right.
So I've seen people in the past, they think, well, I see that pressure is getting built up, so I want to pulse some more off and try to keep that differential almost as low as I can. What does that do? Is that good or bad to do that?
Well, it's a waste. It's a waste of compressed air, and it's also stressing your bags. They don't need to be cleaned that often. So letting that build up and getting maybe 5 inches of water column differential pressure across there before you clean your bags, then you're only cleaning when you need to clean.
It's to improve life with the buildup.
Improve life and less usage of compressed air.
Cool.
And does the buildup on the bags help filter out better media?
It helps to protect the bag, to have a coating on the bag, so you don't want them to be perfectly clean all the time. Mm-hmm. But the dust that we're collecting here is a byproduct of your operation, right? So a lot of plants will want to use that dust for some other operation, or to put it back into the process.
Right.
And if you want to put it back into the process at a controlled rate, so you know exactly how much you're putting back in, pulsing your baghouse based on differential pressure alone, you'll get surges of dust. So you'll get a big bunch of dust when you clean,
Right.
and then not so much, and then a big bunch of dust when you clean. And you could you could run out of dust in the middle of those cleaning cycles. Then that might mess up your process down the line. So
the timing is more for consistency. If you're selling the dust or recycling it.
that's correct. And so, yeah, in that case, you would not be pulsing on differential pressure. You'd be pulsing on time.
There's actually a question from the audience or from the attendees. So you mentioned about 5 inches of water column on when they would pulse if it were dirty. Is there a DP for when after it pulses, or is it?
Well, it's just going to go down. You know, the differential pressure is going to go down. It's just at a certain differential pressure, and all processes are different. And,
Right.
And so 5 inches is not a magic number, you know.
Right. It's just kind of a.
Different. But there is a differential pressure at which you want to clean at, and so it's going to go down, but there's not a low differential.
Right. It's not like it's got to be at 0 every time. It may go down to like 0.5 or whatever, but the key is it goes down.
Right.
So that you're not stressing your system with too high of a differential pressure. Cool. I'm trying to get to the next. Okay, so we talked about the air pressure a little bit, the timing a little bit. Okay, now temperature. So temperature is always interesting.
Yeah. So there's baghouses are used in all kinds of different processes.
Right.
But for instance, if we do what we know best, a drying operation, what do we got? We've got air and water.
Yep.
The water is in vapor form, you know,
Yep.
in the air, but at a certain temperature, that water will condense out of the air.
Yep.
And that causes a problem. It'll cause mudding in the baghouse. So you have to keep your temperature up to above the dew point,
Right.
so that you don't get that mudding.
So one comment I want to make on it, I have personally not cleaned a mudded baghouse, but no one has ever told me they love cleaning a mudded baghouse. So I do know that when that happens, you have to start process, but I know that I've never heard of anyone that's like, oh man, I'm so glad that mudded so I can go clean it. So yeah, it's also a big pain to clean all that.
Well, Tom, nobody wants to get into a baghouse, period.
Awesome. So yeah, I mean, you.
If you're mudding the baghouse, you're also putting moisture in your baghouse components, and that's going to start leading to rust, won't it? And shorten the life.
Yeah, I mean,
Well, and if you have a mudded up baghouse, you're going to turn your dust into a slurry. And screw conveyors aren't made to move slurries.
Right. It's going to basically lock up the screw conveyor and
right.
having other component issues down there.
I mean, and it's not an insignificant amount of water. I mean, just on the stacks, if there's even a little way where moisture comes down, it's almost like a gushing amount of water sometimes. So yeah, and the main point is Tony mentioned above the dew point. That is not necessarily dew point of where you're standing outside. That is the dew point inside the dryer or the kiln in the process. And that's something we can help you guys develop. Excuse me. There is for dryers across the board, there's typically an air temperature value that we like you to stay above, because when that hot air enters the baghouse, it's sufficiently above that dew point value where you won't get muddy or the chances of mudding goes down. Now let's go to the opposite end of the spectrum. It's too high. Too high, you're talking over temping the bags, so now you're just degrading them and any component damage.
Yeah, and so we run into this a lot on people that are trying to do more than just drying.
Right.
If you're drying, then you're looking for a set temperature coming out of the baghouse. You're going to control your burner based on that set temperature. But say you want to do to do heating, additional heating above what's needed to dry. And in those instances, a lot of times the air coming to the baghouse might be too hot, too hot for the bags to handle.
Right.
And it can lead to fires. So a lot of times we'll put a bleed air damper in the ductwork just before the baghouse, so we can suck in just a little bit of ambient air to cool
it back down. We do have another question that says, what is the permissible moisture content in the powder? I think I'm going to break down this question a little bit. There's not really a permissible moisture content because there's 100 different types of processes that we deal with. You can be as low as 0.5% to 2% moisture, or we're talking 40% to 80% moisture. And from a design standpoint, you got to figure out what the moisture is in the airstream volume that's required so that you can go into your psychrometrics and determine the right value from there. So each process has its own limits. It's just, I don't know what your process is. If you guys want to email us in more detail, then feel free to contact us, and I got some contact things we could do at the end.
But a pound of water at any given temperature will only hold so many pounds of right. A pound of air at any given temperature will only hold so much moisture.
Right. So if you're in an area where you got a lot of moisture in the air already, the humidity is high, you may not hold as much. Versus if you're somewhere where it's relatively cool, like in the desert, or not cool, relatively dry, like in the desert, the air will hold more water. So that's part of the psychrometrics or the understanding of the humidity of the air, or the relation. What that is, the relationship between the water and air.
Okay, so we covered temperature. What about seals and leaks? So,
right.
So what we're trying to do here with this piece of equipment is filter, right? We're trying to collect dust. We don't want any leaks. So if you have a hole in a bag, dust is going to bypass. It's going to go off to the exhaust fan. If you have a hole or a cracked weld or something between the tube sheet and the baghouse itself, it's another place for a leak. It's where dust can bypass and go out toward the exhaust fan. So, taking the doors off the top of the baghouse and looking in there, you might be able to see dust. You might not, but that doesn't mean you don't have a leak. So the way to the leak test is moonlight testing. And what we're doing there is we're taking a neon colored powder, and we've got, you can do it with green, with pink, with orange, and you want to do it with different colors, because what we're going to do is we're going to start up the fan, we're going to have this baghouse going, we're going to wait till just after dark, and we're going to pour a 5-gallon bucket or so of this neon colored dust in there.
So typically at night, or better at night?
You want to do it at night, because after we put that in there, we're going to go up to the top. We're going to take all the doors off the top of the baghouse, and then we're going to take a black light, and we're going to find all that dust if it had leaked through with a black light. And so that's done at night, and that's why it's neon colored. If you find some of that neon colored moonlight dust, then you're going to clean it up. You're going to fix the problem, and then you're going to do it again. But you're not going to do it with pink this time. You're going to do it with another color, green or yellow, so you can find out if you have fixed the problem.
That makes sense. And then that's cool. That sounds very.
Had yourself a volunteer for the next job.
Yeah, I'll do it. I'll do it. I mean, doesn't matter to me. And then damper control on causes problems with airflow or preheating procedures, right? So if you don't.
Yeah, so if you got a damper that's not operating properly, you're more than likely your controls are going to tell that fan to speed up or to open the damper as wide as it can to get the amount of air that it needs. But if it's demanding more air, but your damper's not working, well, then you're probably wasting energy, wasting money.
Right.
So you need a good functioning damper, or get rid of that damper altogether and put a variable frequency drive on the fan.
Okay. And the preheating procedures, any comments on that?
Well, when you start up a baghouse, you know, what we talked about, that the dust on the outside of the bag protects it from more dust, the incoming additional dust.
Right.
So we like to have, when you start up a baghouse for the first time, we put pre-coat on it. Pre-coat is similar to the moonlight dust, but it's specifically designed to put a layer of pre-coat on it to protect it from the incoming dust from your process.
Right. Cool.
Like on a new startup.
That's cool. I mean, these are all the subtle details and actually obvious details, but when you dig into it, it's relatively subtle.
You also want to get the whole baghouse up to temperature, so all your ductwork and stuff won't condensate the vapors on it. So, you know, to get the bags up to temperature won't take very long, because it won't take that much heat to heat the bags up. But it may take an additional half an hour, 45 minutes or an hour to heat up the whole baghouse and all the steel components. The steel is what needs to get up to temperature. If you don't, then you can start getting condensation, which the dust will stick to, which will help hold moisture there, which causes corrosion in your baghouse.
And then you mud again in a non-operational way, which is kind of, I'm not volunteering to clean mud. All right, so let's see here. Okay, so on the components, again, I like to reiterate, when the baghouse goes down, you go down, right? I mean, I don't know many dryers that can turn on without air going through it, which means you have to go through the baghouse. So tell me any, so some common failures, I think we chat a little bit about this, is bin level indicators and pulse diaphragm valves.
Yeah, so those are items that aren't going to necessarily shut you down, but there are things that fail often.
Right.
The bin level indicators, particularly if you're using one of those rotary bin level indicators, I mean, it's there so that you know that you don't have too much dust in the hopper bottom of this thing. But it's just an indicator. So
right.
they fail, and then a lot of people just ignore them, don't pay attention to it.
Right.
We'll take care of it when we can take care of it.
Right, right.
Pulse valves or diaphragm valves, they go down, and if they do, you lose a row of bags. You can't clean that row of bags that one's on, but it doesn't shut you down. The one that shuts you down is your screw conveyor components. So if you're collecting all of this dust and then you're cleaning those bags, all that dust has got to go somewhere. It's going to the bottom of the hopper. If that screw conveyor is not working, it's going to shut you down.
Because the dust will just keep going up, up. And then it's just a silo with dust.
That's right.
And then some general maintenance. I mean, these are things I think we talked, but I mean, look at your bags, inspect the bags when it's down, and you could do some moonlighting with the seals. But yeah, I mean, that's not so obvious on the screw conveyor, I guess, until your screw conveyor belt, then it's very obvious.
You really know it. And the seals we're talking about here, you know, those are the seals on the top doors of the baghouse. So if you have bad seals around those doors, you're going to be sucking in a lot of ambient air that you don't have to. So it's a waste of energy.
Okay, cool. And again, guys, on the second handout for the components and services, there is a more detailed, or at least a bigger page where you guys can go through and look at all the spare parts and these things we can supply and help you out with.
Most of this stuff is kept in stock.
Yeah,
in our warehouse, they can ship today.
Yeah, these are all things that we got that we can supply, and actually Tony helps us a lot on all those types of things, and there's a big old warehouse down the street from Louisville that we can ship them out. And I would say these are some of the things as a walkthrough that you could do, and certain things that you could take a look at while you're doing your daily inspections or monthly inspections or yearly. right? Obviously the doors and tube sheets, the air plenum, the blowpipes, how the material is collected and taken away. That's your screw conveyor, your fans. We've had some customers with fans not balanced, and then it's not sucking the right amount of air, et cetera, and et cetera. So there's a lot of little things, and the more we know, the better. That's why I like having the key components.
Another question.
Okay.
Somebody asked, how often should you get in a baghouse to inspect? Weekly.
Weekly is very good practice. Most people don't do it that often. It's very good practice.
So weekly is very good. So what is a normal number that you run into? Never?
When it breaks down, yeah. No, I mean, we suggest monthly inspection inside.
Okay.
But weekly's good.
Yeah, weekly is good.
That's good.
Well, and these guys are, I know these guys a little bit. They have sand, so it's even better to do that, because that's not the
baghouse pretty quickly.
It's not
something that starts going wrong, it's going to expand.
Right, it's pretty abrasive. So this is even better that they're doing that. Okay, so we talked a little bit. So overall, we talked about overall process a little bit, the baghouse, the different types, and a few kind of mechanical things to look at. And now let's kind of switch gears a little bit and go more into the design side, or even after this, if you're looking for a new baghouse, what are some of the things you should do? Or if you have an existing baghouse, what are some of the things you could do to get a little bit either more efficiency or a little bit more performance out of it? So the things we're going to talk about are process evaluation. So one of the things, if you want a baghouse, you need to know how much air and you need to know how much filter area. So one of the numbers you get out of it is an evaluation on the process. So if you have an X amount of tonnage going in with X amount of moisture, et cetera, you have to get that. And from that, you get airflow that determines your fan sizing. Your material that you're processing will determine filter media and the particle size. Your air to cloth ratio is going to be more or less an industry set, and then your baghouse size overall. So again, each process is different. For dryers, it's how much air you need to get rid of the moisture. For kilns, it's typically just enough air to keep that flame temp high enough to create a chemical change. So from a process standpoint, dryers typically for the size need much more air than a kiln of, say, equivalent size. One of the ways to find out is either A, your specs, B, typically the original specs are not the same as the current specs, because let's say you've got a 10-year-old plant, a 50 ton per hour plant at 20 years ago is probably a 100 ton per hour plant today, because we all need to increase production, right? So they may not reflect the needs of what you have from the original OEM specifications. All that said, is this is a way to get your airflow, and from that airflow you can then move that into the baghouse in terms of what you need. The airflow determines your fan size. The pressure drop across the system determines your fan size. It can be really big, like this one, or it can be really small. It depends on what you need. Tony, would you say the Nomex, the air? So this middle one, the fourth one over, the Nomex, that's the trade name, or the AirMed media is the most.
Nomex is the trade name that DuPont gave it, and DuPont no longer has the patent on Nomex, so it's commonly referred to as aramid fiber now.
Right.
So we're looking at the filter media, I guess, so the different types of what their bags are made out of here.
Right.
And the Nomex is the one that's used most commonly in the aggregate industry, which is the industry that I work in.
Right.
But there's lots of different filter media available. If you can get away with, say, a polyester bag, it's going to be far cheaper than aramid fiber bags.
Right. Right, and there's all sorts, and part of that is just your general discussion. But just do know that if you take one bag that was, let's say you get a Baghouse, you talk to Tony, you talk to Mike, you get a Baghouse with a Nomex or an Aramid, and then you said, hey, I want to save some cost, change to polyester. Well, temperature considerations you want to do, how you handle the moisture, that's worth knowing. Maybe the pH is different, that matters. Abrasion resistance. So you may save cost, but if it muds on the Baghouse, takes your system down, and you're the one cleaning the bags, someone's not going to be happy. So these are considerations that we make, and we go from there. And the type of particle that you have kind of determines the range of bags that you want to use, right? So you've got things that are very, very tiny, things that are relatively large, or you can kind of see, or some things as fine as fumes. But and all those will be factored in as we have that design discussion with each group. Okay, so this is the number that a lot of people talk about with baghouses, your air cloth ratio. What that ultimately is the airflow amount that's required for the system. So if you got a 100 ton per hour system that is doing gravel, and you want to get rid of 5% moisture, and you want to heat it up to a certain point, and you'll cool down to a certain point when it leaves, that will determine how much air your dryer needs. And from there, that air goes into your baghouse. So that's where the ACFM comes from. That's actual cubic foot per minute. So that'll be up to 10. Your bag filter area is the area of the bags. So each bag it's a cylinder, and then when you unwrap the cylinder, there's a square footage, and you multiply by the number of bags. That will be your bag filter area. So you take the airflow, you divide it by the filter area, and you get an air to cloth ratio. Anything guys that you want to add?
That's exactly right, and I guess that there's no such thing as a baghouse that's too large, right?
Right. So I guess then that means there's no such thing as a really, really high air to cloth ratio that's not necessarily good.
That's right. I mean, the more filter area that you have, the better.
Right.
Different industries can tolerate different air to cloth ratios.
Right. So the next one, we'll talk a little bit about the different, this is the kind of the different industries, the different rules of thumb.
Right.
So for aggregate, what are you looking at? So like asphalt or even gravel, pebbles?
It's for aggregate, and for the process of making asphalt, we usually use a 5 to 1 air to cloth ratio, sometimes 5.5 to 1 air to cloth ratio. 5 to 1 is pretty conservative. If it were my plant, I wouldn't have an air to cloth ratio any higher than 5 to 1. Okay,
so that would be kind of the sweet spot. Cool. Let's see, what's some other industries? Any other industries you got that you dealt with, that you got some rough rules of thumbs?
I do not. The only dust collection equipment that we handle on our side is in the aggregate industry.
Okay. Yeah.
I'm not sure about what other industries can call.
Yeah, because the thing is, like, grain maybe a little bit different, or very fine aggregates like sand or powder-like plants. That's even a little bit different. It just depends on what.
And touching on grain, that's something that we should talk about also, is that any product that can turn into a fuel. Okay.
Oh, okay. So
generally don't use a baghouse on.
Yeah, and the ones that do, they typically have explosion-proof locations.
You'll have that, or you just stay away from a baghouse.
Yeah, because it's actually surprising how often some of the grain plants, you really got to watch the actually the humidity and anything that produces a spark, because they'll wet that area down anytime we do some repairs on it.
It becomes a large bomb.
We got another question. Somebody asked how to increase ACR without increasing the baghouse size.
Ah, great question. I don't see where that is, but,
Private message.
oh, okay, well, that's a very good question, and we will cover that in maybe 3 slides. But yeah, there's some cool stuff that we could talk to you about, which is exactly this point here.
So also, the bags will give you recommended airflow through the bags themselves for the different types of bags you're having and the different products are going to be filtering through.
Yeah.
So there's some guidance also from the band manufacturer. So if you change your bag media, then it may also either do a better job or maybe not as good of a job filtering.
Right.
With the same ratio.
Right, because there's all those subtle details in there where,
Different variables you're going to take into consideration.
yeah, I think we just touched probably 5 to 10 just sitting here chatting today, which is neat because, you know, the general consensus is, oh, it's just this thing that you just
Put a bag in. Put a bag in it. It's good to
put
go.
a bag in it and then move on.
Purchasing family these cheaper ones, we're going to save a lot of money. Let's put these bags.
Right, and then again,
Operations is not so happy.
right. So we had a question on what can you do to improve the either the air to cloth ratio or ways to improve the performance. So not everybody can just go out and buy a new baghouse, especially in this market right now. It's not it's tougher to get capital or get approval to get certain things done. Using the design criteria that we just talked about, there's some ways we can work on, and it's each of them have caveats, right, Tony and Mike? My view is anytime you got a way you improve something, there's always something that you take out, and can you live with that?
And the specific question was, well, how do I get more filter area in this thing without making it larger, right?
Right.
So our first bullet point we have here, pleated bags.
Right, which is this.
So instead of having just a cylindrical bag over the top of that cage, you can have a bag that is pleated and you gain a whole lot of extra cloth area without changing anything.
Right. So the general kind of, let's say this is a 6 diameter by 79 inches, 54, 8 inch, 13 to 54. That's quite a bit difference. That's about a 4x, 3x.
Big differences, yeah.
Right, and even the 6 inch pleated is a little bit shorter than the 8 inch, 96 versus 79. So there in itself, you've already gained a lot of filter area.
And they're not, you know, the cheapest bags to buy, but it's cheaper than making a bunch of modifications or having to go out and buy a new bag.
Right. And so that sounds great. So I guess the question would be why not everything be pleated?
Well, it's cost. You know,
right.
They're not the cheapest bags to buy.
Right. And I would say maybe certain processes it's probably not good for it, or in some processes it's okay to use it.
Yeah, so the pleats in these things are very tight. And so you get this valley in between the pleats where the dust can collect and maybe not release as well out of that pleat. So you may not be actually taking advantage of the full.
Right, then it becomes another cylindrical.
So you're someplace in between a round bag and a pleated bag out.
Right.
Yeah.
Right.
So they may say you got, say on the top one, you got not 190. Like,
oh, the blue one. I think the 190 is like a flow, like an airflow. The blue, the 54.
But you're gonna get a reduced.
Yeah, it's gonna be reduced. So yeah, I mean, for you guys that want to get back up.
Just gonna talk about the other changes.
Right. So that's to answer that question on if you don't want to change anything on your baghouse and you just want to change one thing, that is a possibility. Now, just know that the consequence is if it doesn't work, you know, change it back. You got two other possibilities. So So we're looking for air to cloth ratio. So the filter area is something that we can change or try to change. So one is changing the surface area of the bags. The length change is increasing the length. If you got short tubes, short bags, you can change the length. Or I think Tony was talking to me about this the other day, is cabinet change. That's, you're actually dissecting the system out a little bit and actually changing that to add more or less bags.
So changing the bag lengths isn't quite as bad as changing the regular cabinet, making it a longer cabinet. Most cases, cut the top head and just raise it up higher, wrap it.
Yeah, so you
Longer bags.
put basically a spacer in the bag house to make room for longer bags.
Right.
How long is the longest bag you can put in a bag house?
For like a pulse jet bag house, I don't see them much longer than 16 feet in our industry.
And they get pretty tall. So here's a way we could lengthen it. So you got a top section and you got a hopper. So what you ultimately do is cut this middle section out, or yeah, you cut the middle section and you add this, so you effectively lengthen this set.
That's right. And generally the top section is bolted to the hopper. So you just fabricate a spacer section that matches that bolt pattern. And then you're just removing bolts, lifting it with a crane, sliding the added center section in, bolting it up, bolting the top section to the top of it.
That's actually not that bad.
We've done many of these.
Right. So I mean, for you guys that have space or it's a relatively short bag house, that you have this opportunity, let us know and we could help you. So, any other comments on this before I move on to the?
I do not.
Okay, so this one, I think the same pictures though. So this is assuming it's
You can only make it so long, right? Before you can effectively clean the length of the bag.
Right.
So in that case, you're already as long as you want to be, and you don't want to buy a new bag house, so you can actually cut the ends of these units off and spread it out, make it longer, make room for more bags.
Right.
Now your footprint changes. You need a longer screw conveyor. You got to modify the hopper also. Needs a lot more work.
Right. I mean, that's not so. This one is a lot of work, but I guess this one is still, in a sense, a little bit cheaper than going brand new. So I would say the decisions on this is, what do you think you can do? What are some low-hanging fruits that you can do? And is it cost beneficial to go brand new or make some modifications? So, summary slide. This is just to kind of mentally go through everything. Is bag house, any of your dust collection systems, when they go down, it's critical path. Bag house goes down, you go down, because you don't got airflow through your dryer, you don't have anything, because you need to move that moisture out, or you need to move that air out. And if you just blow the dust into the environment, typically you'll have some probably some environmental issues on you. We talked a little bit about reverse air versus pulse jet, the pluses and minuses of each. Reverse air is ambient air going in, high volume, low pressure. Pulse jet is low volume, high pressure. Pulse jet, I think you get a little bit more control. Reverse air, you get a little bit more kind of overall amount and a little bit better life of the bags. Major maintenance considerations. One of the, for me, that I've learned is the screw conveyor. If that's out, you got a silo with dust in it.
Done.
And then to really look for some of the seal leakages. Moonlighting is a good test, and remember, when you do the second test, change that fluorescent color. And then when we go into the design considerations, heat mass balance to determine the airflow. From the airflow, you figure out from the process that's there and the sizes that's there, the amount of cloth or air to cloth ratio that's kind of needed, and then the filter media and the particle size, that'll determine the bag material itself. And then any existing Baghouse improvement considerations, you got pleated bags if you don't want to change anything and you want to try something that's low-hanging fruit, or change or modify some of the sizes where you increase the length or extend the ends.
We have 2 questions that just came in.
Okay, so we're in question time.
One question is, what is the best way to adjust ACFM, damper, fan speed, or bleed air?
Okay. The VFD is really the best way, and it's going to save you a lot of money and energy. And you can get a larger turn down out of a VFD than you can out of a damper. On these exhaust fans, a lot of times we're dealing with a large motor, and say you've got a 150, 200 horsepower motor, you know, a VFD is not cheap for that size motor, but it will save you money in the end. It will save you money in energy savings. The damper, you can only turn the airflow down so much with the damper until it just shuts.
Right.
You don't just turn the damper down to slow down your air. Your motor amperage is going up.
Right.
You get a larger, differential pressure drop.
Yeah, it changes that. Yep.
So you're using more energy if you're using a damper to regulate your airflow.
Right. And then on the bleed air, I mean, that's mainly to control the temperature. If you don't have enough, if the temperature is not so high and you're okay, it's more.
Yeah, you would never bleed air in just for the purpose of changing airflow. It's
right.
Just a waste.
Yeah, you're just adding cold air into your system unnecessarily.
And then the next question we got was, we have another question that needs to do.
Okay, yeah, no problem.
How often should I do a moonlight test?
Annually is how often you should do it, but certainly right before that EPA guy gets there.
Absolutely. That's actually a very, very, that's annually in a sense.
And then our next question is, what is a common lifetime for filtering bags?
There is not a common lifetime. It'll be different for different industries. It'll be different for the way that the unit's operated. That's a lot like trying to determine how long this light bulb above my head will continue to burn.
Oh, that one's not very long. I've seen that one turned off. But
I don't like your tires on the vehicle.
Yeah, you can pop it whenever. The shortest life I've seen was like maybe a week.
That's some abuse.
Right. Yep. It is very similar to the tires in the car.
Normally, you should get 6 months, a year, a couple of years out of a bag if everything's running nice and people are taking care of it.
Asphalt plant industry, they last several years.
Several years. Okay. So your magnitude is in the year time frame and not necessarily.
If everything's sized right, the airflows are right.
Taking care, making sure that you're not having upset conditions that affect the bags.
So the answer is some years with lots of caveats. Okay, let's see.
Question, or was that?
That is all I have so far.
Yeah, and so overall, we appreciate everyone sitting through the webinar. We got another question. All right.
Okay, the next question is rotary valve an exit of screw conveyor to maintain sealing, or can it be replaced by something more efficient? In this case, powder for exit of baghouse is recycled back to process.
Okay, so the rotary valve is the kind of the industry standard, and it's there to keep air from coming in the bottom of the baghouse. When people have a problem with the rotary valve, that generally gets replaced by a double dump valve. And the double dump valves do a very good job. They last a really long time. They can handle abrasive products, but they're expensive. So most people use a rotary airlock.
Right.
That's the alternative to a rotary airlock.
Right, that makes sense. So overall, I think it's been relatively clean. So for you guys that kind of want to see what what all we can do, you know, and I'll go through this. If there's additional questions, we'll answer them as I'm talking about it. Is Industrial Kiln and Dryer can do a lot of the spare part supplies, that whole catalog, that there is a brochure that you guys can download that has a lot of the parts that you can ask about, and we can supply them. Almost all of them are here in Louisville that we can get to you. Mechanical inspections, leak tests, or moonlighting, if you want someone to kind of help give you a second opinion, second look. Any of the sizings, custom fabrication, or any of the part installations we can help you with from Industrial Kiln Dryer. On the Optimus side, any of the process audits, training, any resizing from a design standpoint, heat mass balance, that's a real common one that we do. Pressure temperature management discussions, system sizing, and any major design considerations, or even minor design considerations.
Yep, another one from the same person. Does the double duct valve help dust flow better as compared to a rotary valve?
You get more surges with a double dump valve than you do with a rotary airlock. So the vanes on a rotary airlock, normally you'll have 6 or 8 vanes on a rotary airlock. So you've got, for each revolution, you've got 6 or 8 dumps, so to speak. With a double dump valve, you're going to get a block of dust that is going to dump out all at once every time the double dump valve actuates. So it'll move it just as well as a rotary airlock, but you're getting more of the plop 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 surges than you would get with a rotary airlock.
Right. So with pneumatic discharges, that give you problems with your piping at times if you switch over? You get a little bigger dump down into your pneumatic system?
You do, but if you're using a pneumatic conveyor to take away that dust, I mean, they're generally so far oversized that it's not an issue. It'll just blow it right out of there.
Well, we still got a few minutes. If you guys have any other questions, because we're gonna say our salutations and make. Oh, there we go.
Same person. So we use a screw conveyor, but with plug with current rotary valve. That's really not a question.
Well, again, after the webinar, if there is a lot more discussion that any of you guys want to have, feel free to contact us, and we'll get the correct key account specialist to you guys, so we can build on top of this conversation. Other than that, hey, we appreciate the attendees. I love the amount of questions that we got today, and the overall discussion with Tony and Mike. Thank you guys. Without further ado, hey, we appreciate you guys attending, and have a great rest of your day, evening, wherever you're at.
Thank y'all.
Thank you guys. Bye.